All right, well, welcome everyone. I'm Jan Hofmeyer, the Vice President of EC2Edge Services at Amazon Web Services. And great to be here with you at reInvent. I hope all of you are enjoying it. How many of you managed to see Adam's keynote this morning? A few of you, fantastic. Well, what an exciting keynote. There was obviously great news around what we're doing on the AI side with the NVIDIA and Anthropic and all the layers of the stack. One of the things that was, for me, just reinforcing when I was listening to this was just that whole message of reinvent and how we're constantly reinventing, thinking about like the storage, how do you make it faster? We make it cheap first with Glacier, then make it super fast with the new single zone S3. And that's really what we're doing at the edge. Is constantly thinking about how do we reinvent and change how we operate and how we run at the edge. An exciting one for me out of Adam's one, and it's a little bit out in the future, is, and I think it's very relevant for this audience, and today was that announcement around Kuiper with the satellite. I think as we think about the edge, it's as you go deeper into the edge, connectivity becomes more and more difficult and not always available. And I think with Kuiper and bringing connectivity anywhere on the globe, is going to be a real game changer for us operating at the edge. So really looking forward to see how Kuiper and the edge all comes together. All right. So in the past 12 months, we have launched a broad range of new services, exciting programs, features that empowers our customers to run more applications on-premise and at the edge. And today, I'm going to share some of these recent customer stories with you, and then we'll look at the innovations at the edge and in the past year. And I'm honored today to have Yun Shi here from CEO of Acton with me today. Yun flew in from Taiwan to share with you how his company is empowering smart manufacturing in its global manufacturing sites with hybrid and IoT services. So look forward to that. Thank you for joining us. So let's dive in. In the past few years, organizations of all sizes are moving to the cloud faster than ever before. The cloud delivers a range of advantages, including low cost, increased agility, and faster innovation. It also accelerates digital transformation by providing access to hundreds of tools that are only possible with the breadth and services and scale that comes with the cloud. And to support this shift, businesses need to be able to seamlessly operate a broad range of applications wherever these applications need to run. And while many of these applications can easily be migrated to the cloud, right, customers are telling us that some of their applications need to be either re-architected or modernized to be able to, so that they can move it. And a few of them will actually remain on-premise and remain at the edge. And we see that the key reasons why applications remain at the edge and not migrating into our regions or into the cloud is typically around low latency, local data processing requirements, data residency, and migration and modernization are some of the key reasons why we see applications remain at the edge, and we're going to go through all of those today. So let's first start with low latency. And I'm going to take you through a couple of customer examples just to give you a sense of how customers today are solving problems at the edge using the cloud. So many of you have told us that you need real-time access to your workloads with minimal delays to improve the application performance. And you want those applications to run where your users are or where your data is residing. And a great example of this is Nasdaq as a first customer example, right? Nasdaq markets are responsible for seamlessly transacting hundreds of billions of dollars a day, serving millions of investors globally. So underlying infrastructure needs to be hyper-scalable, ultra-resilient, and highly performant with ultra-low latency. At reInvent 2021, Nasdaq announced a multi-year partnership with AWS to migrate its US equities and option markets to AWS. And just 12 months later, Nasdaq announced that it had migrated the core trading systems of one of its 6 US option exchanges to the cloud using AWS Outposts. The new edge compute solution using Outposts improved performance by 10% and delivering low double-digit microsecond latency from order to trade processes for NASDAQ. And then 2 weeks ago, NASDAQ GEMX became the third exchange, market exchange, to migrate to AWS just in the last year, processing 12 billion daily messaging. Prior to this partnership, this is a great example. Financial exchanges was often considered as the type of workload that would never migrate to the cloud due to the complexity of the latency. And it's fantastic to see how NASDAQ have already migrated 3 exchanges, and we look forward to working with them to migrate the rest of their exchanges in the next year or 2. Another example is Liberty Latin America. In times of emergency and ensuring that we have the voice and SMS services are available at all times can be a matter of life and death. And Liberty Latin America, a leading telecom provider in Latin America, acquired 1 million subscribers in Puerto Rico, and they needed to support that and bring them onto their systems. With the nearest AWS region in IED, so in Virginia, Liberty built a resilient, scalable infrastructure closer to its subscribers in Puerto Rico, using both AWS Outposts and AWS Local Zones. The solution achieved a 5.9 availability and provided subscribers in Puerto Rico with connectivity to its business support systems with under 20 millisecond latency. Another one I want to call out is Mercado Libre. It's the largest online commerce and payment provider in Latin America, and its business has rapidly expanded to 18 Latin American countries with over 100 million active users. Some of its operational technology, or OT, workloads in its distribution centers are extremely latency sensitive. Mercado Libre has developed a variety of workloads, or deployed a variety of workloads on Outpost racks, including their automation systems, for their facilities, their Wi-Fi access point controls, as well as their physical access control systems. Building on the success of Outpost racks, Mercado Libre is now testing the Outpost 2U server for automation and robotics control services. AWS fully managed Outpost plays a key role that allowing Mercado Libre to run applications seamlessly across their entire geographical presence with centralized management and consistent operations while leveraging AWS in-house know-how. The next area is around technology. As we see maturing technologies like IoT and artificial intelligence and machine learning, we see that these workloads are generating a large amount of data at the edge. As an example, if you take a network, for instance, and you take one of those network elements that today runs on physical hardware and you virtualize that and move it to the cloud, it can easily generate a petabyte of telemetry data per day. So a large amount of data being generated at the edge. And according to various sources, there are approximately 15 billion IoT connected devices globally today, and they believe that this number will double by 2030. So for these applications to be viable and efficient, the data must be processed close to the point of origin or consumed by end users. The first customer example that I want to call out here is Orange Business, who has built a private 5G network in a stadium to bring innovation experiences to its fans. These innovations require a tremendous amount of data that's being processed that must be accessible locally in order for ultra-low latency connectivity to generate real-time results. Here are just 2 examples of what they've done. The first one is they combine the advantage of 5G with artificial intelligence to index athlete photos during a match in real time, making it easier for them to quickly generate the most relevant and brand compliant photos with fans around the world as the match is still unfolding. The second application or example that they've used it for is for extending the excitement of what's happening on the pitch to fans' fingertips with an interactive augmented reality application built from digital twin. This is where fans on the stadium can use their phones pointed at the field, and the information then gets augmented with the player, the statistics about the player, and additional information in real time as the game unfolds. Another example is Apollo Hospital, who has deployed an AI-enabled detection system in a 5G network using Snowball Edge. This system augments the doctor's ability to detect precancerous tissue and smaller, flatter polyps that may go unnoticed by just using the human eye. This helped improve the physician's accuracy and allow them to deliver better preventative care for patients. The third area is around data residency, and it is a critical consideration for organizations that collects and store sensitive information, such as personal information, financial data, healthcare, and data from national critical industries. So as you operate in new geographies, it can be challenging to ensure that your data is in compliance or handled in compliance with those local laws and regulations, which could result in slowing down your ability to innovate. With AWS Hybrid and Edge services, you're able to gain control over your data while still innovating fast. So let's take a few examples here. First customer example here is MTG Research and Development Labs, who developed a data science pipeline and analytics code for healthcare providers involving large amounts of data. MTG runs locally on hospitals using AWS Snowball devices. Researchers can now analyze data while complying with HIPAA and regulations and GDPR in half the time and at lower cost than traditional on-prem solutions. Next example is FanDuel Group. This is the leading sports company in the United States, who has accelerated its business expansion into the US and improved user experience by standardizing on AWS across both its cloud and on-premise operations, using AWS Local Zones and AWS Outposts. With consistent APIs and tools, FanDuel was able to standardize its deployment, allowing it to quickly deploy production-ready instances of its sports betting platform in approved locations within state boundaries. This has greatly helped FanDuel comply with state regulations and data residency. So what were they able to do with this? Well, as a result of this, FanDuel managed to accelerate their time to market for a new state to operate from between 15 to 16 weeks to less than 8 days start to finish. And this was the first time this happened was with when they started operating in the state of New York. This first mover advantage for FanDuel allowed them to gain 40% market share, which is about $6.5 billion worth of market share, and a 48% revenue share, about $650 million revenue share in the state of New York in the first year of operation. So huge time to market advantage. In addition, FanDuel was able to improve overall performance by 30 to 40% running on AWS Outposts compared to their existing or the previous on-premise solutions. So while most workloads can easily be migrated to the cloud, some workloads need to remain on-premise to access legacy operation systems or databases where the data lives. So let's look at a few examples of how AWS Hybrid and Edge services ease cloud migration for applications with on-premise dependencies. The first one is Vector Limited. It's the largest distributor of electricity and gas in New Zealand. It manages a rapidly expanding energy distribution system or network across the Auckland urban area, servicing approximately about 30% of the New Zealand population. So to power the electricity distribution network of the future, Vector needs a reliable, secure, and performant infrastructure for its mission-critical distribution systems. The system has specific data residency requirements and needs low latency to its on-premise OT networks. So Vector deployed the GE's Advanced Distribution Management System, or ADMS, on AWS Outposts and leveraged a combination of AWS native controls and existing security appliances to implement security controls aligned with the Purdue model for industrial control system security. The solution enabled zero-touch automated deployments of the GE ADMS system. This facilitates near real-time geolocation view of the electricity assets within their plant, and that's how they manage then outage management and rapid response. Next, I want to bring up ABSA. ABSA Limited is one of Africa's largest diversified financial services group. So let's hear from Robert Suarez, a principal engineer from ABSA, and see how ABSA modernized their critical data infrastructure using Outposts and Local Zones.
Several countries have very specific requirements around where their citizens' data can be kept. And without solving this challenge, we couldn't continue to progress with our digital transformation journey. We've moved over 100 workloads out to the AWS Cloud. We've launched over 100 new cloud initiatives in the last 3 years. And in part of that analysis, we found a specific workload, our data engineering and analysis service, ripe for disruption, but had some very specific data sovereignty and regulatory requirements that meant we couldn't simply push it into AWS public region. Leveraging things like Outposts and AWS's Local Zones really gives companies the opportunity to intelligently place workloads to meet regulatory requirements while also being able to maintain a common set of APIs, common automation, and common services. We're also able to leverage Amazon Kinesis Firehose, Amazon Backup, Amazon SSM, and Amazon Route 53 to do a variety of different tasks that used to be manual. And so we were able to focus more on delivering the service and less on delivering the infrastructure. So for our customers, that means we deliver better solutions faster, better services faster, better capabilities faster. We allow our engineers to focus more on new product delivery, product enhancement, service enhancement, and delivering better data insights through this particular service rather than day-to-day operational work.
Excellent. So from all these customer stories, there's something very consistent coming out of that. They are all asking for the same reliable, secure, high-performance infrastructure, a same operational consistency, same services and APIs, the same tools, automation, deployments and security controls, and wanting to do the same pace of innovation that they do in the region. And that's what we bring with AWS Edge, bringing it on-premise. We always start by working backward from the needs of our customers. So at AWS, our goal is to keep bringing AWS wherever you need it with a truly consistent experience. We don't speak enough about this, and I wanted to bring this because it's such an important part of how we manage to bring this experience to the edge, and that is our AWS Nitro system. It is the core of delivering this sameness. The AWS Nitro system is the underlying technology for EC2 instances that enables AWS to innovate faster, further reduce costs for our customers, and deliver the added benefits like increased security and new compute instances. This same AWS Nitro system is also the technology that enables the creation of the hybrid cloud and edge services like AWS Local Zones and AWS Outposts. What's exciting about bringing Nitro into the hybrid and edge infrastructure is that it's really the first time that customers can take advantage of the innovation in the cloud wherever their application runs. The actual hardware, the full system, all of the security, and the performance advantages, all of this now right in your own data center running on our edge sites. At the core of Nitro, there's really three primary aspects. The first is the AWS Nitro cards. These have custom ASICs built by AWS that enables super high performance I/O virtualization. So this is what runs the VPC networking, as well as the storage with elastic block storage or the instant storage. All of these, in all of these three cases, we're able to do full line rate encryption, enabling by these Nitro cards. So if you think about a traditional and most other implementations today, the hypervisor as well as the control from a cloud perspective runs on the actual computer, on the same CPU, memory, and disk that runs in the computer. So you share with the workloads. With Nitro, we move that all off onto dedicated hardware, and the entire server is available for the application. So we do not run on the server itself. We run completely separate in this Nitro hardware. Second is the Nitro security chip. This is a security chip, with security being so important at the edge as well. This is a security chip that sits on the motherboard of all of our servers. And that ensures that from a Nitro perspective, everything about the hardware is secure from boot up as well as during operations. And finally, we looked at the hypervisor requirements. And we realized we could greatly simplify the functionality by leveraging the Nitro cards. This is where we were able to take all of the network and storage off the server into the Nitro system. And that leaves us with a very thin hypervisor, the Nitro hypervisor, that gives us near bare metal performance on our servers. There's a A couple of key, you would expect here, capabilities of the Nitro. So you have encryption, you have the secure boot, you have no remote access. The one I want to focus on, and it's so important, we do this in our regions with millions and millions of servers, but we also do this on the edge with Outposts and Local Zone, is our ability to patch the systems without impacting your workloads. Because we run everything on the Nitro cards, we have the ability to patch in real time and doing live updates of the software while your workload is running. And that's how we also maintain the ability to always be updated and running the latest version of code on our systems. And then there's a little device here that I want to share with you. We love innovation, the innovation of the Nitro system, but we wanted to have an extra layer of security that is particularly important at the edge. I don't know how many of you have operated in data centers, and I've seen firsthand the processes that you have to go through to secure the media, the hard disk drives and the SSDs in a data center, right? This is where you have to make sure that when a server gets removed, right, that all of that media gets removed from the server, it gets destroyed. And it's a very difficult process and a challenging problem for our customers. What we've done is we created this little Nitro key. This is the encryption key that is used, that encrypts everything on our servers. This key sits on the back of the server, and it has a little screw that holds it in place. And when we come in, for instance, to replace a server in your data center or wherever they run, we remove this little key. There's a little hex marker here where you turn the hex key, and it crushes the chip. And that basically does the equivalent of a cryptographic erasure of everything on that server. And you can then send the server back to us knowing that there's none of your data is exposed on the server. So great piece of innovation for supporting the edge use cases. All right, we talked about the performance and the security benefits of Nitro. Then we started to think about how can we bring the same security and performance benefits to wherever you deploy your applications, whether it's in a metro area, on-premise, or at the edge. This way, you could build application once in the AWS region and deploy it anywhere you want in just a few clicks. You could then operate these applications with the same security model and expect the same performance as in the region. That was our mental model when we started building our continuum of the hybrid cloud and edge services. And this is what we've done so far. The continuum of hybrid cloud and edge services goes all the way, starting at the AWS region. Then we move to major metropolitan areas and industrial centers and even locations within 5G networks. We're moving on-premise. We offer solutions for data centers to remote and many times rugged environments, sometimes with limited or no connectivity to the cloud. And finally, to end devices, running at the far edge in cities and factories and automotive, wherever you see IoT devices run today. And if you notice, the arrow goes both ways. We recognize that some of the applications are built in the cloud, and our customers want to move them down into the edge. In other cases, we have applications that was born at the edge and wants to connect into the cloud. And we meet our customers on either way in their journey, wherever they are in their journey, with a broader set and deeper set of capabilities across compute, storage, network, and IoT that helps them securely run their applications wherever they need them. So the continuum starts with the AWS regions, providing the widest range of services and offerings to our customers. It is important to know that our regions, and if you this morning were with Adam's keynote, he touched on this as well, there are typically 3 or more availability zones, every one of our regions, each of which is one or more fully isolated, discrete data center. So we don't share any critical infrastructure between our availability zones. And those regions support the more than 200 services available on AWS. So if you have a workload, that's where you want to run. If you can run in the region, that's where you have all of the services and all the capacity available for you. I'm excited to share that this year we've expanded into 2 new regions in Melbourne and Tel Aviv, bringing AWS global infrastructure to a total of 32 geographic regions representing 102 availability zones. We also announced plans for 4 more regions in Canada, Israel, New Zealand, and in Thailand. So if you can't run in a region, and we spoke about those reasons before, either latency, data residency, or data gravity reasons, the first area you can then move closer to your workloads is with metro areas, is with Amazon CloudFront, Amazon Local Zones, and AWS Wavelengths. So let's dive into each one of these. So CloudFront uses AWS Global Network and integrates with the AWS services to give developers and businesses an easy way to distribute content to the end users in low latency and high data transfer speeds. It is one of our foundational AWS services that customers choose for reliable, high performance, and secure delivery of web applications. In addition to thousands of external customers using it, our internal services like Prime Video, Audible, and Amazon.com deliver content using CloudFront. And just to give you an example, just during the Prime Day event alone, our CloudFront handled over 1 trillion user requests as part of Amazon.com Prime Day. With this year's expansion into Peru and Nigeria, Amazon CloudFront now has a total global network of more than 600 points of presence and 13 regional edge caches across 100 metros and 50 countries. CloudFront also supports application acceleration, not just video streaming acceleration at the edge to significantly enhance your application performance. The first is CloudFront Functions, available in hundreds of our CloudFront POPs, and it's ideal for high-scale and latency-sensitive operations like HTTP header manipulation, URL rewrites. So these are short-running, lightweight operations that supports traffic that can be extremely spiky, or unpredictable. Next is our Lambda at the edge that serves as a serverless capability, allowing you to execute more complex, long-running functions at our CloudFront regional edge caches. Our service, AWS Local Zones, lets customers meet latency, local data processing, and data residency requirements in more locations without deploying on-premise infrastructure. In 2022, we started the expansion of local zones in metros outside of the US with the launch of Delhi and Taipei local zone. And then since then, we've launched an additional 15 local zones in metros outside of the US. We also increased the capacity in Dallas and Phoenix by launching a second local zone as a result of the growth of consumer demand in those areas. So today we have a total of 33 local zones around the world. And we're really excited about the growth of local zones and how it helps customers. And we plan to expand to 18 new locations and 16 countries with our local zones. To help you deploy your application to more locations, Local Zones supports a core set of compute, storage, and database and other services. This includes EC2, EBS, ECS, and EKS for hosting your applications, along with foundational network services like ALB, Direct Connect, Route 53, and Shield, which helps you ensure a safe and scalable network on connectivity. And then based on feedback from customers, we've added services and features like FSX, RDS, NAT Gateway, and Elastic Cache to select local zones. In addition to local zones, local zones are also connected to their parent region via AWS high throughput and low latency backbone, which makes it easy to leverage all of the services running in the region. So if you run in a local zone, you still have access to all of the region services, and you can take advantage of that through our backbone. This enables you to use CloudWatch, CloudFormation, System Manager, CloudTrail, just to name a few, for deploying and monitoring your application at the edge. Just to touch on wavelengths, it is a public MEC solution that embeds the AWS compute and storage services within a telco 5G network, providing mobile edge computing infrastructure for developing, deploying, and scaling ultra-low latency applications on 5G edge devices. And you saw the earlier example with Orange Business taking advantage of this. With this launch of a new zone for British Telecom in Manchester, Wavelengths now is supported in 3 locations across the world. So as with metros and telco networks, we have enabled hybrid and edge applications to be deployed and operated within your on-premise data centers. AWS Outposts is a family of fully managed solutions delivering AWS infrastructure and services virtually on any on-premise or edge location for a truly consistent hybrid experience. I'm going to double-click on when we say fully managed. That means that the AWS systems that manages our servers in our own data centers are also managing these servers running in your data center. When there is as an example, when there's let's say a memory DIMM that has 10% error on it for whatever reason, our systems that monitors in the region will monitor it in the Outpost running in your data center, will detect that. If we see that there is it degrades your application performance, we will notify you and say, hey, we're going to replace that server. And AWS will send a new server, replace the server, and make sure that you are up and running again. Our Outpost solution allows customers to extend the native AWS services to on-premise. It's available in a variety of form factors. We have a 1U and a 2U Outpost, which is ideal for locations with limited capacity. That's typically not a data center environment. Think of restaurants and clinics, manufacturing sites. And then we have our 42U Outpost racks that's ideal for deployments in your own data center or in your colo facilities. Like local zones, Outposts can run some of the AWS services locally and connect with a broad range of services available in the local zone or in the region. So just to calling out a few of these services. Local to the Outpost, your application can use S3 on Outpost for object storage, EKS and ECS for container workloads, RDS on Outpost, and Elastic Cache for high available and high performance databases. And we are constantly innovating and looking for new services to bring to Outpost, bring on-premise to support our customers at the edge. So back in July, we introduced Amazon Route 53 Resolver on Outpost, which allows you to resolve domain name server queries locally on-premise. When you enable Route 53 Resolver on Outpost, Route 53 automatically stores DNS responses locally, and it provides a continuous DNS resolution service, even if you lose connectivity to the region from your Outpost. By serving DNS locally, you also dramatically improve the performance of your application, both and on-premise. Optionally, you can also connect Route 53 Resolver on your Outpost with DNS servers on-premise using the Route 53 Resolver endpoints. Another exciting service that I'm very excited about was when we launched in this year was the intra-VPC communication across multiple Outpost racks without the need of network traffic traversing back to the region. So in the past, if you had 2 Outpost installations, and imagine you use them in a redundancy, the communication between the 2 systems would have gone through the region. So with intra-VPC, we now allow connectivity between the Outpost that stays on-premise and does not have to traverse across the region. So this greatly improves the application performance and reduces the latency between Outpost instances. And finally, a service we introduced is S3 replication on Outposts that extends S3's fully managed approach to replication to Outpost buckets, helping you to meet your data residency and data redundancy requirements. So with local S3 replication on Outposts, you can create and configure replication rules to automatically replicate your S3 buckets between Outposts on your local network. You can monitor replication processes by tracking the bytes pending, the operations pending, as well as the replication latency between your source and your destination Outpost buckets using the S3 Management Console or Amazon CloudWatch. You can also set up event bridge notifications to receive replication failure notifications to really diagnose or correct any configuration issues. And we continue to expand Outpost. We are now available in 76 countries and territories around the globe. So one of our customers that we've been working with very closely with on Outpost is Acton. Acton is a manufacturer of networking solutions that have shipped over 8.7 million units of networking products. It enables smart manufacturing in a global multi-site using Outpost. So to that end, I would like to welcome Jun Shi, the CEO of Acton, on stage. Jun, thank you very much, and please take it away.
Thank you. Thanks. Thanks, Jan. So Acton Technology is a service company. Right now, we have a market cap around 10 billion market. And it's more about a service company. We offer design, manufacture, and development for networking equipment as the premier providers. And we grew up as the ODM providers, primarily focused on the networking equipment, switch, wireless, when expanded to the contract manufacturing. And then in the past several years, we grew a lot with building business for joint development across switch, AI engines, and the fabric. Actually, you can see from a lot of fabric we are building for the AI, ML. And further, in the past many years, we invest a lot into the open networking, contribute into both hardware, into OCP as the open computing network, and turned out to be a leading contributor to the software like a Sonic in the community as well. And we pretty much cover the whole spectrum of the networking market, from data center, cloud infrastructure, enterprise campus, all the way to the AI ML. And since we offer these services across the globe as the leading providers, manufacturing definitely is one of our core competencies around the globe. These are the few of the locations, actually, we have our global manufacturing locations and warehousing around the globe, like in China, like in Taiwan, several places, and in US, California here as well, because meeting America, meeting the US momentum. And then more at the developing momentum right now, given the geolocations, geopolitics around the globe, more and more countries right now are trying to build in-country manufacturing capacity, but they lack of the know-how. So we kind of start to provide the manufacturing as a service to help them to grow the manufacturing capacity from development assembly line all over the world. And these are the few of the countries, for the example, for the CCAR conversation, we kind of export our know-how, like our manufacturing line from the OT and IT system, ERP system altogether, to help them to grow the manufacturing capacity to build such capability locally in different countries. Since we offer this kind of service not only to internal, but have to offer to external as well, we have to consider both the OT and the IT system together. If you look into a typical OT infrastructure from the manufacturing lines here, as you can see from the bottom, we kind of provide from the manufacturing line, from the SMT line, to the assembly line, then to the testing station, to the packaging, and then to the shipment end-to-end. In addition, in order to maintain the surrounding environment in a healthy situation, we provide a lot of sensors, a lot of tooling over there for IoT to make sure the surrounding environment is running in a very healthy, efficient way. So this OT infrastructure, as you can see, come along with a lot of new intelligence we bring in to provide a very efficient productivity and quality assurance through a lot of AI ML. Right? This has been in the wild deployment from our locations around different locations already for the PCB, for example, inspection, and for the testing inspection, and for example, the packaging inspection altogether. So this is more about the OT part from the manufacturing. But for majority of our customers as of today, we offer the EDI interfacing with our enterprise customers directly. So basically, we interface with their IT system and work through the CRM, the product line management tool, PRM, and the tooling management, all the way take the ticket in from the manufacturing requirement to generate the ticket along the whole IT system from manufacturing floor management, the build management, and the shop floor build management. The shop floor is the product actually we have pretty much cover the whole life cycle from the very beginning, from the material, loading up the material, all the way to the shipment end to end. So given our capability to enable ourselves and our global partners together, we have to build a hybrid infrastructure here at the global scale, because not only try to automate everything, but every single country, every single customer, especially given a lot of geo politics or the data residency or sovereignty requirement, we have to offer a hybrid infrastructure for both OT and IT. So given this is the current structure we have, or before we adopt Outpost. So what we have from the OT infrastructure, we kind of train a lot of algorithm about AI ML using AWS, for example, like a SageMaker, and use the Auto ML for the ML ops. And then after training this model, we populate those trained model, go into the on-prem, doing the inference close to the manufacturing floor. And then we apply all the inspection over there for the quality assurance. And in addition, for the IT system, for example, like the ERP system, and the shop floor for the build management, which is interfacing with our partners, for example, the EDI system, we either can put onto our on-premise right now, right? We maintain our own rack, our data center, or we host them onto AWS Cloud directly. And from the manufacturing perspective, the productivity and especially try to keep the manufacturing line in place is very critical. We cannot stop the line. Every single second counts for us. That's why for us, we need a very high, reliable infrastructure over there for redundancy and the disaster recovery as well. Because the fast response from the failure, it will be very critical for us to do the recovery to get manufacturing back online. So we rely on the cloud as our disaster recovery, in addition to the active like reliability on-prem. And we maintain quite many of the Kubernetes clusters as the primary and the backup on the floor as well. So this is just to try to give you a snapshot view at a high level to see how it looks like. At the top level, it shows just quite a few of the automation is in our manufacturing fab running on the daily basis. At the bottom, as you can see, we adopted quite much of the AI ML during the inspection. For example, from the installation assemble perspective, when the human being, the worker is doing the assembling, actually the camera is monitor that one to make sure there's no missing part. And meanwhile, after the assemble, the AI camera over there will do the inspection to make sure the quality is assured. And as you can see in the past, as a human being, as a third picture, it may take about 40 seconds try to do take one human being over there to use the eye to inspect the quality of the manufactured part, but right now it goes down to 7 seconds. To put everything together, definitely there's a lot of a challenge, especially given the global manufacturing and the service, more and more countries and customers are demanding or require us to put our know-how over there in different locations. So the diversifying of the demand request coming from all over the world right now, this is where the manufacturing and the service right now going beyond the region in our past. So if you look into the different locations, for example, like in developing countries or in the much more developed countries, the running environment are quite different. For example, just like a private line over there, we may take it for granted in North America here, the circuit is quite cheap. But compared to that one, in the developing country, it turned out to be very expensive. So how we work out or work around it or design around it. And the time to market and the time to value are always very important. Okay, we have been optimizing our productivity and efficiency in the past many years, even without AI ML. And I'll give you an example. Very recently, we built up a manufacturing house in Vietnam. After we get the building over there at the ground zero, from the ground zero to all the way get a full manufacturing line up to the full capacity, it only takes us 4 months. Right, just think about it. But the goal here is 4 months is still too long enough. Then the matter is how we can further reduce this one to months or weeks or even much shorter. So as an adoption from the AI ML, right, as you can see, we do a lot for training and inference, especially using a lot of AWS service for the training and apply to the on-prem. There's a performance requirement because on the manufacturing lines, we have so many parallels. The line running over there take a lot of inference from the GPU over there. We have to maintain the response time from the GPU from inference level on the premise to quickly feed back to the manufacturing line without stopping or slowing down the process, try to gain the high efficiency. And meanwhile, given the emerging or evolving the Gen AI perspective, we kind of bring the AI ML, the Gen AI, for the new use cases. For example, for the video labeling and the tagging, use the Gen AI to help our engineering peoples to reduce the amount of time for the labeling and the tagging of the image or video. And given this adoption at the global scale, how you manage the AI ML models to be deployed at the different locations across different countries, not to mention we have to manage in the different customer locations, given the geo or the local regulation, there turned out to be a challenge. So for sure, the last not the least one is really try to leverage this is a cloudification, as Yan mentioned, from the management service cloud perspective, because we want our people to focus on our core competence to manage our workload, to generate a high efficient productivity, rather than to manage the infrastructure about the server or the memory over there. That's where the agile operation, rely on the DevOps, rely on the CI/CD model, and adoption about the OT-IT convergence turned out to be very critical. So this is all the reasons behind for us to move step further to adopt Outpost. Okay, because we have to consider both of the OT and IT together onto one single architecture. Because we have an IT resource constraint over there, we really cannot scale that big. That's why the management service from the Outpost Cloud through the cloudification is a big help to us. So just look into this picture. This is about the OT part migration onto the Outpost. We have a manufacturing floor, as I mentioned, show the picture from the assembly line, manufacturing line, inspection line, all the way to drive the inference, where we host the inference model onto the Outpost, where the GPUs will help us to drive the faster response over there. Then we can deploy the AI ML models in a very fast and agile way. And meanwhile, for the other service, for example, because we rely on quite much of the AI ML, we do the training, and we do rely on the service sitting in the cloud. We use Direct Connect, AWS Direct Connect, and the VPN service from the on-prem directly talk to the cloud service together. So the high performance, low latency definitely is very critical. Other than the Outpost itself, actually we have been adopting AWS IoT side-wise as well to put all the sensors on our smart chambers. And that one can drive a lot of monitoring efficiency improvement to save our power from the overall chamber operation. Then beyond the OT, it really comes down to the convergence about IT on the same infrastructure. This is really the ERP system, the IT system, or the global war room for the monitoring pieces. We kind of run on our prem. But this is a little bit different from the OT, because the OT has a lot of countries, even including ourselves. It's very stringent for us to keep the data on-prem. It's not allowed to leave the data out of the premise, out of the country, or out of the region. So data sovereignty is very critical. But for IT, there's a little bit of flexibility over there. We rely on the IT, for example, like an Outpost, but it runs in the hybrid mode. Some of the workload, if we really cannot scale locally, we can burst to the cloud. That's the nature of the hybrid cloud deployment. We take advantage for that one. And the last not least one is really about this high availability for the active and active for the redundancy. Meanwhile, we have to consider all the disaster recovery because we really cannot stop the line. So this is where, actually, as I mentioned, we have been adopting the Outpost for quite much of the convergence between the IT, OT. And we started with Vietnam and Taiwan. This is where the orange color we get started from the AWS Outpost as a convergent platform for both IT and OT together. But moving forward, we try to bring this one. You can think about it. We can preload Outpost of the rack. We can ship and drop it in the different manufacturing floor in different countries. And we can manage them all remotely altogether. So as a takeaway, right, there are a few things I want to highlight. The first one, the cloudified hybrid OT and IT convergence is very critical for us. And the faster deployment for the service rolling out from months to weeks or days. No, actually, I want to push to the hours to as fast as possible for the fast adoption. The last not least one, definitely the high reliability, performance, and the data sovereignty will be the key for us to moving this forward. Thank you.
Thank you so much. Thank you very much.
All right, thank you.
Excellent. Well, Yoon, thank you for sharing with us. You know, I moved into the new house. I think it's a year later. I'm still unpacking a new building, an entire line in 4 months. So unbelievable, unbelievable. All right. Well, thank you for that. Let's go to the far edge. And this is where we are extending the AWS Cloud and services to the furthest and smallest part of the edge. You know, these are many times locations with limited connectivity or sometimes no connectivity with the cloud. You know, think of construction sites, think of mines, on ships, and autonomous vehicles and airplanes. AWS Snow Family enables customers to deploy AWS-based solutions to capture, transform, and move data from the rugged mobile edge locations to the cloud. AWS Snow Cone is our smallest offering, and it's ideal for non-traditional and portable use cases such as satellites and aerospace. We now have our Snow Cone device both in the International Space Station as well as the Japan Space Station in space, using Snow Cone for analytics and inferencing up in space with photos being taken. The AWS Snowball, it's a larger compute-optimized or storage-optimized capabilities that once again is designed to operate disconnected or in rugged environments. So you can cluster these together as well and create bigger clusters of storage if you need to, and deploy it anywhere in the world. So on Snow, we've added support for virtual machines on Snow, and we see the shift to virtual machines. And so one of the things we hear a lot about our customers is containers and container orchestration with Kubernetes. So we've added the support for EKS Anywhere on Snow that gives you simplify your process for setting it up and gives you a consistent experience between Snow and running EKS in the region. We also announced the availability of S3 compatible storage now on Snow. That also gives you the benefit of running multi-node S3 clusters on multiple Snow devices, again, giving you that consistent experience between running on Snow and then also running in our regions and Outpost. Let's really go to IoT. You know, AWS IoT is the deepest and broadest set of services and partners that make solutions available for our customers to securely build, manage, and scale IoT applications. And these IoT applications can be built and be deployed and operated in the cloud, on-premise, on Outpost, Snow, or on a variety of third-party devices. So let's just go through a few examples of the IoT services. First, we have the IoT Core. That lets you connect billions of IoT devices and route trillions of messages to AWS without messaging infrastructure. The IoT Core manages today 270 million unique devices connections per day. Next is our IoT Sitewise. This was specifically built to operate at the edge, helping customers to collect, organize, and analyze data from industrial equipment at the edge without the need to develop additional software. IoT Greengrass is an open source edge runtime that allows you for service to be built and deploy managed at the edge. And then we have IoT Fleetwise, specifically for automotive applications, again for collecting, transforming, and transferring vehicle data to the cloud in near real time. And lastly, we have IoT Express Link, and this is a AWS-designed and architected network solution that gives you secure connectivity that is implemented by our partners and made available as a partner solution. There's a lot more we can talk about IoT. I would encourage you, there's a whole IoT track at reInvent, so if you're interested in more detail around IoT, I would encourage you to go to some of those sessions. All right, I want to bring us in. Data sovereignty. I don't know how many of you have been hit or have had discussions around data sovereignty, but it's a hot topic at the moment. Data residency has become more and more critical consideration as organizations expand into new geographies, and as governments and standard bodies are continuing to developing security, data protection, and privacy regulations. Businesses and organizations that collect and store sensitive information subject to this data residency landscape are really facing with challenges. How do you comply and how do you support that? So according to the European Center of International Political Economy, 137 countries have established data protection and regulatory laws for compliance. And customers are really struggling. It's a real challenge for our customers. So we announced, like a local zones and outposts that already solves our customer residency challenges today, we have announced or launched the availability of AWS dedicated local zones. It is a new type of AWS infrastructure that is designed to help our public sector and regulated industry customers meet stringent security and compliance requirements to run their sensitive and data application workloads. So I'm going to take you through one of our examples here is Government Technology Agency of Singapore, which is GovTech. It's a statutory board of the Singapore government responsible for implementing the country's smart nation infrastructure and applications. GovTech also sets technology direction for more than 70 government agencies and operates the government commercial cloud that hosts the agency workloads. So GovTech collaborated with AWS to define and build dedicated local zones to host the government confidential workloads. With confidential systems moving from on-premise to dedicated local zone, automation is now possible, reducing human error and accelerating innovation. Then I want to quickly touch base on what we're doing in the telco space. So in telco, you heard it in the keynote today, it's around reInvent and how do we help reInvent our customers. And in telcos, we are doing the same and helping them reInvent their networks for the future. And if you think about they come from a world where their existing systems are bespoke solutions that was built over many years to run their networks, but they have a keen interest to take advantage of the cloud, the elasticity of the cloud, the pay-as-you-go model of the cloud, and the scalability of the cloud. So there's a key driver for them to move to the cloud. And this is for across their business systems, their core network, as well as their RAN networks. So if you look at the telcos, at the end, today they have to build and provision the entire network for their peak traffic. And whenever there's a change, a new application that comes in, or a new business requirement, they have to make modifications that takes them a very long time. So with the cloud and the ability to expand in the cloud, they are able to rapidly expand and respond to customer requests and customer needs. So it gives them the flexibility of the cloud. A key move in the telco industry is where they move to microservices with their new 5G architecture that allows them to now break up these workloads and run in the region. The workloads that are not latency sensitive, run in local zones, or run in outposts on-premise to support their networks. We also, to help them run these networks, we launched a service called AWS Telco Network Builder. And think of it as the CloudFormation for applications today. It's the automation system for building networks that we make available, making it much easier for our telco customers to deploy, manage, and operate their networks. I'm running out of time, so I'm going to skip. I had a really cool demo here of using AI for how to detect your network, see how it's deployed, where it is deployed, if there's any issues within the network. But I'm going to unfortunately have to skip that. So to sum up, what we discussed today is AWS created a truly consistent cloud experience from global regions to the rugged edge that allows our customers to accelerate innovation with access to the broadest and deepest set of tools and technologies. Last, I would recommend that you, as part of the hybrid edge, we have some great sessions around themes of migration and modernization, data residency, low latency, as well as AWS at the far edge. We also have some deep dive sessions with job talks and workshops that take you through very practical architectural patterns and implementations. And finally, there's a super cool, I'm not going to detail, there's a super cool demo on the floor using machine learning. It's called Drone Inspector, and generative AI for controlling a drone and doing an inspection of a bridge. And if you have time, go do that. If you're good at interacting with a drone, you can see how many objects you can detect in a period of time, and then they will give you a fleece jacket if you can achieve that. So definitely go check that out. It's very, very cool. So last but not least, I really appreciate you being here today. Thank you for, and we appreciate your feedback. So please fill out the session, a survey, and locate it inside of your reInvent app. And thank you so much for your time today.